Hi, this is problem 919. I did all of that work and then the video crashed on me, so I'm going to repeat what I said. Problem 919, when a person wins the Dreams Come True lottery, I'll let you read the problem. It's in your packet, but I retyped it here. And I forgot 0.84, so I wrote that there is a 0.84 here I forgot to type in. Alright, so in this sentence right here, it continues. In this sentence, at this rate, they only need to deposit 368,000. I hope the video doesn't crash on me again. It's doing weird stuff, but okay. So I'm depositing this, and the account will be zeroed out after 19 years. So at the year 0, I'm really depositing that much. 368,288.84, whatever that is. And then at year 19, I'm getting 0 money because they gave me that. So before even looking at the table, which you'll find those 2 points given in the table, you can figure out those 2 points from that line right there on top. And then they asked us for the average rate of change over 19 years. So you just do the y minus y, x minus x, and make sure you're doing it right. That's what I was doing with that arrow. So I did y value minus y value, and then I go back and do this x value minus this x value. So don't do it as 19 minus 0, unless you did 0 minus 368, 288, whatever. So make sure that you do it correctly, right? So if you go this way, you go this way. If you go backwards, then make sure you're consistent. Okay, so you get negative 19,383, whatever that is. So that negative right here means that the money is decreasing, right? So that's very important to note, that the money is decreasing. Now, if we go to the next question, question B, it's asking us if the payments are 50,000 per year, why is the balance not in the account not dropping by 50,000 per year? And it has something to do with that interest right here. Because yeah, the amount is dropping by that much, negative 19, that much, but I am getting money from my bank because I have a 12% interest. So it's kind of making up for some of the difference right here. So they're giving me money. Yeah, my money is dropping, but they're also giving me money. So it's not showing that it's dropping by that much because I'm getting more money from the interest. All right, let's look at the graph for question C. Again, it says use a calculator, but I am aware that we all don't have calculators, so we'll do it manually. Let me show you the graph. So this is the graph. Again, I put the 0 a little bit away just for you to see, because I want you to see the points that I plotted, right? Except for that 19. But I want you to see the points that I plotted, but then the 0 should be on the origin, right? Okay, so that's just for you to see, because I didn't want you to get confused by putting points on there, but that's okay. So this is the graph that I did manually because I wanted to show you that it can be done. And it says describe the graph, so you're just gonna say it's a curve, looks like a half parabola, looking almost like that. Okay, so now let's move on to question D. It says calculate the actual change in account each year. So you're gonna take the interval between each year right here. So from 3 to 2, from 4 to 3. So I'm not gonna do that for you because it's a lot of work. But what's happening is that you're doing the same calculations that we did for those 2 points right here. But you're doing it for each 2 points that you have. Okay, so I'm not doing that part. E, do any of these match the average rate of change for 19 years? And again, the answer is no, because it's not dropping by the amount of money that we figured out. We're getting more interest. So it's not matching the answer to question A, where it was negative 19,383 something, as I remember. So just if you go back in the video, if you pause here and go back, you're gonna find that we figured that the first question is negative 19 something 383.62, and that's definitely not the case. It's not dropping by that much each year, and it's showing in the table as well. So it's a repetitive question. Is the average rate of change per year increasing or decreasing? Well, it is like decreasing. So make sure that we're not going upwards like this. It's not that I'm going upwards so that it's increasing. It is actually decreasing, right? Because I'm starting at 0 and then going down. So if I draw lines like that, oh, whoops. Okay, I'm not unable to draw lines, but if I draw a line here, draw a line here, draw a line here at between each 2 points, you're gonna find that the average, the slope is being more negative. Yeah. So at each point, even if I do it as tangent, yeah, again, I don't know why I'm unable to draw lines. That's okay. If I do it as tangent to this parabola right here, like half a curve, you're gonna find that the slope is decreasing. So we know that. So make sure that you're not looking here and say, oh, it's going up. It's not. It's going down. Okay. G, describe the concavity. I'm unable to pronounce words. All right. Concavity of the graph. In part C, is the graph concave up or concave down? What does it tell you about the slope? Okay, so obviously it is concave down. And we agreed that, yeah, it's going down like that, so the slope is decreasing. So those are repetitive questions. The big thing was to draw a graph, and don't get intimidated when they say, enter this data in your calculator. If you don't have a calculator, just do it manually. No biggie, no problem. Do it manually, and you're going to find that you can do it. It's not that bad. Okay, let's move on to the next question. Okay, 930. Your bank offers an interest rate of 4.88% on savings and says that the APR is 5.00%. That is, if I invest $100, after 1 year my bank account will have 105 in it. Assume that the bank rounds correctly to 2 decimal places. All right. So what is the minimum whole number of times the bank compounds my interest? Okay. So if we input all of the information correctly in the formula right here, or the equation, you're going to find that the resulting amount that they gave you is 105 and the deposit amount is 100, 1 plus, and the rate, right here I want to explain that they said your bank offers an interest rate of 4.88% on savings and says that the APR is 5. So the bank is really offering 4.88. That's what they're really offering. Now, they're saying, when you walk in the bank, they're saying, okay, I'm going to give you 5% interest rate. But that's not what they're really offering. What's really happening at the bank is it's 4.88. So that's why I plugged in 0.0488, because 4.88%, change that to decimal as we agreed, then it's 0.0488. Now, if I'm getting confused on that formula and what those letters mean, you need to scroll down to the video that is on the blog for problem 918. I posted that a couple of days ago to help you. So that problem is on the blog already. Scroll down and find it. Okay, so if you look at this question right here, question 8. What is the minimum whole number of times? So no decimals for n. N represents the number of times. No decimals for that. Whole numbers. So 1, 2, 3, 4, any whole number. What is the minimum n that the bank can compound? Now the bank is promising you $105 when you deposit $100 at, they're saying 5%, but really what's happening is 4.88. So now, what is the minimum number of times that the bank should compound to keep their promise, to keep that 105? So if we try 1, for example. So let's make a table for this. I think that would be really helpful. Okay, so this is the formula. I'm going to make a table where I'm going to try n. and I want the resulting amount to check as 105, and we're assuming in the question, we're assuming the bank rounds correctly. So if I get 104 like 105.1, that's 105, right? But if I get 104.48, that's 104.5, so that doesn't check. So you see, we're rounding to 2 decimal places to get that 105. Okay, so we're gonna try ends. By the way, that T over here, I didn't plug it in. I plugged it in as 1 actually, because they're saying in the problem that we're gonna get 105 after 1 year. So n times 1 is n. Okay, all right. So if I try 1, I would get 104.88, which is already under 105. So that doesn't check. I can't accept that because the bank promised me 105. So the bank is obviously not going to do that for you. So they're going to have a minimum amount of times that they compound to keep their promise, right? So it doesn't check because we're running to 2 decimal places right here, and that didn't reach 105. So let's keep going. So if we keep going and plug in 2, 3, 4, 5, you're going to get numbers. And then when you reach 19, you're going to get that number, which we're running to 2 decimal places. So that's 99 right here, because that 4 won't bring that 9 to 10. Then this is to 10, so this to 5. At year 20, it starts to get really close, because if we're rounding to 3 decimal places, that's like 995, right? So if I want to cancel that 7, 9 and say I'm rounding to 3 decimal places, it's 995. So that's really close. And then to 21, I'm rounding to 2 decimal places, and it actually checks, and that turns to 105 when we're rounding. So the instance, the packet is giving us a minimum amount of 20. I can accept 21 actually to be more accurate. But you see how that worked? We're just guessing and checking based on this formula. Now, the second question, or question B, what is the maximum number of times the bank compounds my interest? Well, if you keep going, you're finding that it really doesn't make that big of a difference in total. Like even if we keep going 23, 24, 25, 37, 40, 50, it doesn't make that much of a difference. So let's try the continuous compounding formula. It means that we're going to compound forever, like kind of infinity. It doesn't have a limit. So that formula is P to the RT, and we're going to try continuous compounding. So it compounds forever and ever. And that year we said that we're going to get 105, depositing 100, PE, RT, and T, we said it's 1 year. So if I plug the stuff in correctly, I have 100 e to the power of the interest rate. Now, would that equal 105, or would that exceed that, so that I have to double check all of the values to find the maximum? And if you do that on your calculator, you're going to find that it does equal 105, 0.0010. So if we round to 2 decimal places, like the bank in the question says, assume the bank rounds correctly to 2 decimal places. So if we do round to 2 decimal places, we're good. Now, question C, we're assuming the bank is giving exactly 5. No rounding. How many times is that count compounded? So now, in that case, we need to work it out. Because if the bank is giving 5%, so instead of 0.0488, so that's, I'm doing question C, they're saying it's going to give 0.5 exactly. We're saying if that's the case. Now we need to like really keep going on our table right here to figure out that actually I think it's after the year 122 or 123 that it's gonna be really over 105. So you really have to guess and check more to figure that part out. So that's a lot of work. I'm going to leave you to do that. And that's it. That's all what this problem is saying. Hope that helps. Thanks.